Next, I'm going to introduce one more example on the analysis of a portal frame. A portal frame is shown in this picture. This is a portal frame under the vertical load V and the horizontal load 8. Okay, at this the middle of the beam BD, and at D the horizontal load. So we have two load, vertical and horizontal load. The column has a height of 8, small 8. The beam has a length, had a span of L. Then the load is at the middle. C is middle. So the portal frame A, B, C, D, E. The redundant. How many redundant? One. Okay, one redundant. Then we have at least two plastic hinge is required. Okay, two plastic hinge required. The requirement of this problem is to determine the limitation value of 8 as a function of MP. So we assume the section of the frame is identical and the moment plastic capacity, plastic moment capacity is MP, and we have to determine 8 and of course V as a function of MP. And we assume L over 8 equal to 1 means the length of the column and the beam is identical. And the ratio between V and 8 is 3. Mean V equal to 3 times of 8. Okay. So determine 8 as a function of MP. This frame can be divided into two structure. This structure is determinate structure. Okay, determinate structure. No redundant here. Okay, determinate structure. We change this into this one. Okay, determinate structure and plus this one. Have shear here, and this structure can be divided into two parts. Okay, then with each part you can plot the moment and shear force diagram for the upper part. Okay, it is due to the applied load only. We can plot the moment diagram of this frame like this. So just make the portal frame straight on. We have A, B, and C, and D, E. A, B, C, D, E. Due to 8 here, a shear here, then we have moment here is 8, upper 8 and lower 8. And this one is 8, upper 8, more 8 divided by 2 because of half this one. And this one is due to this one. Okay. This is moment diagram. Okay, moment diagram of this structure. And this total here is this one. So now remember the moment at C equal to this one. Okay, equal to this one. And moment here is equal to this one. For the lower frame, due to this redundant shear reaction, okay, horizontal reaction. It is redundant. We have moment diagram is like this. Okay, moment diagram is like this. The value of the moment here is S multiplied by this one. Okay, so now we can use a superimposed method. Then we have this moment diagram, the whole moment diagram of the structure ABCD. Moment here is S MP equal to at 8, and how about moment here? This equal to MSC equal to this one and minus MP because MP equal to this one. Okay, MP equal to this one. This is MP, and the total is this one. Then now we have MC equal to this one, and it's equal to MP. It's also equal to MP. Then we have two hinges, two plus the hinge. And by using this equation, we can determine H. Here is only one unknown. H equal to 1.6 MP divided by the 8 is the height of the column. Okay, and this is solution. Now, if L equal to 8 equal to 20 feet, and if we use this section, okay, then let's determine the limit value of V and 8. V and 8, the vertical and horizontal load. Determine the limit value. First, we consider the problem without effect of action force. Okay, without effect of action force. We have 8 equal to 1.6 MP over 8. That is a solution of previous step. Then we have MPX. MPX equal to, because IK is small, axis, weak axis, okay. In the column, we have to consider the weak axis. MPX x equal to the x Fy. And the x of this section equal to 82.3 multiplied by sigma y equal to this one. And now A is very simple, equal to this one is to here, okay? Then equal to this one. And if we have, because we have 8, then we have V. 3 times of 8 equal to this one. Very simple, right? So with our effect of shear force, we can calculate 8 and V. Very simple. Okay, so please remember here in the column, in the structure, in the frame, okay, in the frame, we should consider the weak axis. Okay, so now we consider the effect of shear force, action force, the effect of action force. For member BD, what is member BD? BD is beam. BD is beam, okay? The beam. The BD is beam. So we have to calculate the load, the action force inside the beam. action force inside the beam. This is tension. TBD equal to 8 minus S. 8 minus S. Okay. It is the load, apply load, horizontal. And S is horizontal reaction of the connection. And we have this is function of MP, and this is also a function of MP, and replace it into this equation. Then we have the action force, it is tension, okay, inside BD. And we have PY equal to A multiplied by FY equal to this one, okay, equal to this one. It is initial ending elastic limit load, okay. We check this equation, we check this condition. P over pi t Pn smaller than 0.2, then this equation is U. Okay, I want to explain a little bit about this equation, the equation. Have you ever seen this one before? I know that some of you already know this equation. If you already taken my class in in the last year, structural analysis, stability structure. Okay, stability structure. I already introduced this equation, but some of you did this first time. So if you are confused with this equation, then please check in your textbook, page number 177. Okay, page number 177. The equation 4.6.1 and the equation 4.6.2 in the textbook. Okay, in the textbook, and you understand why we use this equation. This equation is used for considering the stability condition. Okay, stability condition. The the buckling condition. Okay, so please check if you don't understand. Some student already know. This is not need to check, and some other you have to check to understand this equation. Okay, in the book. So by using this equation, as I mentioned, that we consider the also the effect of the stability condition. That's why we have this equation. So using this equation, we have MPC equal to this one. Okay, this one equal to maybe 0.9 for beam. You can check in the textbook I already mentioned, and it is so that the effect of the action force is small, 0.991, almost 1. Okay, almost 1. So the effect of action force in this case is very small, and it can be ignored. It can be neglected. Okay, so that is the effect of shear force is small. Action force is small. Consider the member DE. Okay, member DE. What is DE? Sorry. What is DE? DE is this. Okay, back one more. Original one. Here is DE. DE is compression, of course. Okay, compression, under compression. The previous one is tension. This one is compression. Okay, then we have to check P in this one, P DE. We have to calculate load inside to consider the effect of the axial compression force. P in the BD equal to V divided by 2 plus 8 upper 8 lower 8 divided by L. We check this equation by yourself. It's not difficult, so you can check, okay? And finally equal to this one, okay? Equal to this one. And now we have to calculate lambda Cy. Have you ever seen this equation before? And do you know why to check this one? For compression, we use the slenderness ratio, okay, to check. For compression, when we consider the action force, the effective action force, we have to consider the slenderness ratio. And if you don't know why, then please check in your textbook, okay, in your textbook page number 1-8. The reason why I don't mention in this lecture is because I already provided in another class. And the equation from 4:16:3 to equation 4 and 6 and 5. Okay, so please check in the textbook to understand why this equation is used for considering the effect of shear force, compression shear force under compression. Okay, then back to this problem, we have to calculate lambda. We have to lambda x and lambda y and lambda x. Lambda y equal to this one. Here KL twelve is the transfer ratio from fit to keep. Okay, this one is fit to keep, but 10 is the length of the column is 20. But in this case, we assume we have a horizontal brace. Okay, so the length now assumed to be a half. So that's why here is 10. Okay, the total length of the column is 20. But we assume there are a horizontal brace. Then the length, the unbraced length is 10 feet. Okay, that's why here is 10. Okay, 10. So the length in y axis is 10, and lambda cx equal to this one. And what happened? Then weak axis control is this one. This one is smaller than 1.5. It mentioned in the textbook. If you don't know, if you have never seen, then please see textbook why this value. And because of that, we calculate Pn equal to this equation. This is equation 4.6.3 in the textbook and equal to this one. And by using this Pn, we can calculate P over pi c Pn, pi c equal to 0.85 for column, and this one equal to here due to here. Then it is P is P here. Then this value equal to this one. And now using this equation again, P over 2 times of this one plus PC MPC over this one smaller than 1. Then we have 0. This one divided by 2 here. MPC over this one, this ratio equal to 0.9 for beam. Okay, for beam. And MP. And MP, we know MP. And the maximum is 1. And now we have relationship between MPC and MP. MPC equal to 0.827 MP. 0.827 MP. So we saw that the effect of compression force, action compression force is significant. Okay, significant because ratio is not 1 but 0.8 something. So it is significant effect. Okay, compression, action compression force. So now we have 8 equal to this one. Okay, we already mentioned equal to this one. MPC. And also V equal to 3 times of 8 equal to this one. So this is solution. Okay, so we already mentioned analysis problem of bottle frame. We consider also the effect of tension force and action tension force and action compression force in the member. Okay, so in chapter 2 we also mentioned the effect of action force and shear force. You remember? And if you understand, and if you remember, you can realize that the equation is different. Okay, so my question is what is different? Why it is different? In this case, we use different equation. In chapter 2, we talk about different equation of the effect of shear force. Okay, so please, as your homework, don't need to report, but maybe you have to answer this question sometime in exam something, but think about what is different and why different between this equation, the equation and the equation that we already mentioned in chapter 2 when considering the effect of shear force and action force. Okay, it is different, but why? Please explain. Okay, homework number 7. I will give you one problem, only one problem. Problem 4.12 in the textbook. These simple homework problems in page number 220 in the textbook. It is fixed end beam with 20 feet long in the reinforced, and it's required to design a cover plate. It is very simple problems.